So I'll be also keeping an eye on the chat so that if any comments that you are making, I can keep track of it. If you need to stop me, ask me a question, you can ask over there. I will just answer the question verbally over the mic. Okay, right. So we looked at the video. Okay, this video is available on YouTube. So anyone who wants to have a relook at it can. Okay, but Ali here is going to actually redo that. How many of you felt that the lady over or the narrator in the video was actually speaking quite fast? Okay, only Srita has started refraction in school. Are you in Sec 2 or Sec 1, Srita? Vika has not done the topic. Lydia is doing it right now. Amias is doing cells now. So you can tell that many different schools are doing different things in school. So it's impossible for me to do the same topic as you. Okay, so it's always my job to actually pick out a topic that will be useful for everyone. Okay, clear? So when I pick up a topic, I'm usually picking out a very useful topic that will answer a lot of questions. And if I go through the questions that come out in the exams, it's going to be useful as well. And this lesson is recorded. You can watch it again. So means that whenever you come to the refraction chapter, be it in maybe in July or August, you can come back and then re-listen to this lesson again. Am I right? Okay, so the lady in the video mentioned a lot of things like, oh, the light will pass through a medium. It could just go through it, totally transmitted, or it could be reflected, or during transmission, it could get bend. Okay, bending of light as it passes from one medium to another. The key word here is the medium. Okay, I'm going to highlight here into another. Okay, the key word here is light has to go from one medium to another. Be it, okay, what are the different mediums that we will be coming across? It could be air, could be glass, and light also can pass through water, okay, and so on. And these are where the light is transmitted through, so it's transparent, right? Of course, you can say, oh, what about other mediums like metal? Okay, then the light does not pass through it at all. It's just blocked. So we do not have any bending of light. Like for example, you see this one. Is the light going through to the other end? Yes, so it's transmitted. So it cannot be metal. It cannot be a mirror as well. It should be glass or water. So that's what I mean by defining the medium, where the light is traveling. So I only drew some parts of the ray. You know what a ray is? The black line. Can you see the picture with the black lines? Not the red line, but the black line. The black line not only is a black line, it has an arrow to it. Okay, I'm going to highlight that to you. It's very, very important. Black line has arrow, but the red line doesn't have arrow. Why? Because an arrow represents a ray of light. So that in the exams, when you draw, right, the teachers can see, are you drawing a ray of light or just drawing any line? Because some people, you know, the red line, some people draw the normal as a dotted line. Okay, it can also. There's no standard. You can draw it as a full line also. It's also a normal. Can you see where's the normal? The normal is this. Okay, drawing is going to be really important in this chapter, and how you draw is going to be really important. That's why I'm teaching you the basics right from the beginning. Like, do you have to draw with an arrow or no? So you don't put anyhow arrows here. Okay, don't put anyhow arrows here. Okay. Later, you will learn in another third part of the topic called lenses. In light, we have another topic called lenses, where a double-headed arrow, something like that. I'm just showing for those people who know or may be interested that a double-headed arrow actually means a lens. Okay, let me repeat that. A double-headed arrow means a lens. It's like everybody in the scientific world will know this. So I don't even have to write lens. I just draw it there. They already know it's lens. Why? It has arrows on both sides. So it's lens. Got it? Then if it has arrow only on one side, for example, in a optical diagram like this, it definitely means light ray or ray of light. That's what I've just mentioned just 2 minutes ago. And if it doesn't have any other arrowhead, then you can call it a normal or anything that you might want to label. Sometimes if you think the teacher is not going to know what you draw, you can actually label it, right? You know about labeling diagrams. So here, that's why it's labeled as incident ray. How many of you can see the word incident ray here? So it's already labeled. If that is the incident ray, okay, so let me erase everything so that we can focus now. If that is the incident ray, that's the ray that is coming in. Therefore, it's called incident. Okay, then there's another ray here, right? That's going out. It's also a ray. You can call it going out ray. You can call it incident ray, exiting ray. What do you call it? Yeah, there are a lot of words. Is it an exiting ray? Yes, maybe it's exiting, going out of the glass block. How to term it even nicer than that? Okay, it's called an, in scientific words, we use this word called immersion ray. So the opposite of incident is not reflected, not reflection ray, because it not reflect. Okay, Lydia and Srita, yeah, maybe refract. Refract will be the one inside. Srita, you say refract, right? That is going to be here. Okay, Srita, this is going to be the refractor ray. Means refract means bending, the light that bend. Okay, so we call this the emergent ray. And then Lydia said reflection. No, Lydia, reflection will be like this. The one that is reflected, it bounce off. So that's reflected. Clear? So I'm trying to go and do your misconceptions a bit. Okay, so this not reflection, is not a refraction, reflected. Though you could say refracted as well, Srita, because all the light that bends, right, is called refracted. Because refracted if essentially means bending, bended light or bend light. Can you see on top the line on top says bending of light as it passes from one medium to another, refraction of a light ray in a glass block. So what Srita said was the light that is coming through here. Okay, so I should draw it a little bit more straight, or maybe I should draw it in black also so that is clear, or maybe in yellow. Let me just choose a color. Okay, let me choose a color that is very, very obvious to you. Okay, this line is the, as Rita said, is refracted ray. So we're just learning how to label it, right? Can you see now the difference? The three parts. One is incident. That means the light that is coming in. So people tell you, Srita, on the phone, she's talking, your friend is telling you, hey, can you look at my incident ray and check if I drew correctly? So you know exactly what she's talking about. She know that you want to check the incident ray, not the emergent ray, because the emergent ray, she got it correct. So she wanted to do correction. She said, can you look at my incident ray? You know you're looking at the top. If I talk about emergent, it also can be called the reflected ray, right? Can or not? Because it's bent as well. As long as there's a bending when it's coming out, here it's going into the glass, this is coming out of the glass, as long as the medium is changing. For example, you go into the bus, you feel the aircon, suddenly you feel cool, suddenly you react, you say, wow, so cooling, thank God, right? Then you take out your jacket or something, it's cool. You do that, right? Or you do take out your jacket, sorry, you put on your jacket, right? And then what happens is when you leave the bus, then it's so hot again. Then you'll be like, oh no, I'm wearing my jacket. I better take out my jacket. You do two things. When you enter, when you exit, you do something different. Same thing for the light. When it enters, when you exit, it bends because the speed of the light is going to be different because there's not much resistance. Just like your aircon, something like that, or the speed of the light because it's a denser medium. So we'll be talking about density soon. Okay, so let's go past this slide so we can move on to the next better parts. Bending of light as it passes from one medium, another same thing, but now the reflected ray has been drawn in through using a computer so that it looks much clearer. Okay, all good. So then you have the reflected ray. This is how you draw. Okay, yes. Now Srita on the chat, if you want, you can, it's actually messaging to the teacher only. All of you actually can change your chat to like, when I message, it will message to everyone. Because I believe you're not going to spam the chat, right? You're going to ask intelligent questions. So if everybody can see the questions. So these comments on the chat can either come to me and only I can see it, or you can choose for all your classmates to see, which is easier so that I don't have to repeat your question. So you can just choose on when you're typing, it says to Ali or to everyone. If you put everyone, then throughout this lesson, it will be to everyone. So try and put to everyone so that your questions, there are no questions that are not good. All questions are good questions. So I'm going to answer them all if I can, right? So her question was, incident and emergent ray, must they be parallel? What is she talking about? This is the emergent ray, right? She's asking, must these two be parallel? Question mark. How to spell parallel? You all also must teach me. A lot of you get this wrong. Must they be parallel? Okay, yes. Okay, unless they are going into another medium that, like, okay, for example, from here, and then there's water here. So there's glass and water. What will happen? That won't be parallel. Get the idea, Srita? And the rest of you, Amias and all that, can you all understand what I'm trying to say? Now, because it's air to water, the bending is by this much. If it is from water to air back, the bend will be same. Same thing like what I discussed just now. When you go into the bus, you put on your jacket. It's too cold. When you get down, you take out your jacket, right? So you do the same action. So it's exactly the same. You look back, you look the same when you come down. However, if you go from the bus, then you went into interchange and it was cold. Yeah, common sense, right? And then you change to MRT train, which is sometimes colder than the bus. How many of you feel MRT is colder or bus could be colder? Some days different, different train, different bus, different. Then you may have to feel even colder. So you start putting on a scarf or some gloves. Okay, this one, okay, not so dramatic or drastic in Singapore, but let's say if it's in the overseas during winter, it's probably even colder and getting colder and getting colder. Then you may have to put on more and more gloves or socks or something like that. Then the emergent ray won't be the same. Then the behavior is different, just like how you behave, the light also behave. And that's exactly what I've drawn here, because here is a glass block and water. And then, so I should go back here and draw water. And then it's not going to be coming out straight away like that. Okay, it's probably going to bend a little bit further. You see this part, you draw another normal. Then you have to determine whether the density of water is more or less. Okay, this is a bit advanced, but this one I'll teach you, or it will bend this way. Okay, this one I'll teach you later. So it won't be parallel. That will answer Srita's question whether it's parallel or not. So it's only parallel if there's only one medium, meaning you only took one bus and so on. Okay, so far so good. Okay, we clean up everything, answer the question already. Okay, we spent nearly what, 20 minutes. Of course, 3 minutes was the video, and then we spent 20 minutes just to present you the premise of this whole chapter. I hope you all are okay with my speed. Okay, if any questions, just post it up there.